Hello, students. I have a friend here with me today, and his name is Mr. Light Bulb. This person enjoys watching news. But do you know what is his favorite kind of news? It's current affairs. Well, you got the objective right. Today, we're going to study the concept of current. Let's watch this. As you can see, when the electrons are flowing, that is, when the switch is on, the electrons are flowing and the bulb is lit up. So it's basically the flow of electrons or the flow of charge is what is making the current. So we can say the charge in motion constitutes the current. We very well know charge is represented by the letter Q. So current is represented by the letter, I'm sorry, current is not represented by the letter C. It is rather represented by I. I'm sure you wonder why. It's because earlier days it used to be called as the intensity of current, based on the French phrase intensité du courant. So let's define current properly. Say you have a wire and there are a couple of electrons flowing through a particular cross section. Say A is the cross section of the wire. So let's see, there are so many electrons flowing through the cross section. Let us take the total charge, total number of electrons, so the total charge is Q, which is flowing through the cross section in time t. Then the formula of current would be charge upon time. So we can say current is the rate of flow of charge across a cross section of a wire. A particular cross section of the wire, you have electrons flowing through that cross section in a particular time t. And the total charge carried by that many electrons upon time is given as current. So let us understand now the unit of current, SI unit of current. We know the SI unit of charge is coulomb and time is second. So obviously the SI unit of current will be coulomb per second. But in order to honor the physicist André Ampère, the French physicist, we also call the SI unit of current as ampere. Right? So I is equal to Q by T, and Q is the total charge, which is nothing but NE by T. Now you can see in these two pictures, in one picture there is large current flowing and in one picture there is small current flow. Large current because of good number of electrons flowing through the cross section in 1 second. And if there are less number of electrons flowing through 1 second, definitely the current is going to be less. Right? So let's understand what is 1 ampere. When we say ampere is the unit of current, SI unit of current, how much is 1 ampere? I should be able to visualize how much is 1 ampere. Okay, 1 ampere is 1 coulomb by second. But 1 coulomb, if I have to visualize how many electrons contribute to 1 coulomb, how many electrons together have a charge of 1 coulomb? Yes, you're right. 6.25 into 10 raised to 18 electrons make up 1 coulomb. And if that many electrons pass through 1 second, pass in 1 second through a cross section of the wire will be called as 1 ampere. That many electrons per second. But there can be smaller units of current like milliamperes. Milli stands for 10 raised to minus 3. Micro, further smaller. And further smaller, nanoamperes. But students, remember when you are doing sums in current electricity, your units have to be in SI unit. So these conversions have to be kept in mind. Let's proceed. We know metals are good conductors of electricity, and so in metals, it's the free electrons or it's the valence electrons which are constituting the current. But electrolytes or some ionized gases are also good conductors of electricity. In that, the moving charge is not the electrons. They are the cations and anions. That is why we say that the charge in motion constitutes the current. The charge can be free electrons, the charge can be cations, which are positively charged, and anions are negatively charged. So it's the charge in motion which constitutes the current. Now, when we say the electrons are flowing, that means the electrons have a direction. Here we can see the electrons are flowing from negative to the positive end. So if the electrons have a direction, the current is rate of flow of electrons, which also has direction. Direction of current is opposite to the direction of electrons. Now this is actually the conventional direction. Conventional means we are considering the flow of current from positive to negative. Just like we know heat flows from higher temperature to lower temperature, or water flows from a higher level to a lower level. Similarly, we say current flows from positive to negative. That is the conventional direction of the current. So yes, current has magnitude, which is measured in amperes, and current also has direction. So current is a scalar quantity. Yes, you may wonder. Current has magnitude, current has direction, but still, yes, it is a scalar quantity. Let's understand why. Because it does not follow vector addition. Then let me simply give you a simple example. 3 amperes plus 4 amperes is 7 amperes. This is simple maths, or this is simple algebraic addition, which is followed by all the scalar quantities. Had it been a vector, it wouldn't have followed this kind of addition. So remember, current is a scalar quantity, although it has magnitude and direction. Now, we know current can be measured. It is a physical quantity. But what is a device which measures the current? The name of the device is ammeter. So, now when you go into your physics lab and you need to take up an experiment, how do you connect this ammeter? You need to first show the circuit diagram before you connect. So when you draw the circuit diagram, the ammeter is joined in series in a circuit. Now what do you mean by series? You can see the circuit has key, cell, ammeter and load. They are connected one after the other. That's series. Also, very important point is the positive of the cell is connected to the positive of the ammeter. This is very essential in your circuit diagram. And once your circuit diagram is correct, then only you attach your cell to your ammeter. So let's summarize. Charge has the symbol Q, unit coulombs. Current has a symbol I, unit is amperes. Let's understand the formula. Let's summarize. I is equal to Q by T. I have a very easy way to remember this. I always say I am QT. And so are you. I am means equal to Q by T. Okay, so remember this simple formula, which can also be equal to NE by T. So based on this, let's take up one sum. In a conductor, 6.25 into 10 raised to 16 electrons flow from its end A to B in 2 seconds. Find the current flowing through the conductor whereby the charge on an electron has been given to you. So you can see the electrons are flowing from A to B. Mention what all is given to you. You have been given the N, number of electrons. You have been given time, 2 seconds. And you have also been given E. Since we are asked to find the current, I is equal to Q by T or NE by T, by substituting, simply we will get the answer, which is 5 into 10 raised to minus 3 amperes into 10 raised to minus 3, you know, stands for milliamps. But here I have mentioned 5 milliamperes from B to A. The direction of the current is opposite to the direction of electrons. So therefore, 5 milliamperes from B to A. You can take up the other sum as DIY. I'm sure you'll be able to do it. You have been given the current in milliamperes. You have been given the charge on an electron. You have to find N. So all the best. I'm sure you'll be able to do it. And I hope the current concept of current has been understood by you. Thank you.